Demonstrate that if two rods having length of A and B move along the coordinate axis in a manner ensuring that the endpoints constantly lie on the same circle, that means they are concyclic, then the locus of the center of the circle is given by the following equation. Let us begin. We'll try to understand the problem graphically first. For this, we're going to consider the coordinate axis and a circle which has both x and the y intercept. So here we have a circle. Let's say circle has the center at C. Now the circle has both the x-intercept and the y-intercept. Now the way the x-intercept and the y-intercept are chosen is very special here. So here, let's say the circle intersects the x-axis at 2 points. We're going to name it point A and point B. Here the length AB is going to be a rod which has a length of A units. Then the circle also intersects the y-axis at 2 points. Let's say it intersects the y-axis at 2 points C and D, such that we have CD, which is going to be another rod with a length of B units. Now clearly we can observe that for both the two rods, the endpoints of the rods are lying on the same circle. Now the question is, if the two rods move along the axis, along the coordinates axis, for example, the rod A, it could move either along on the left side or it could be on the right hand side. Similarly, our rod B, rod of length B, could move upwards or downwards. In whichever direction it moves, it should be such that the endpoints must always lie on the circle, and our goal will be to show that the locus of the center of the circle is given by this particular equation. Okay, so we begin by first considering the general form of a circle. Now for simplicity, we'll assume that the rod AB and rod CD moves along OX and OY respectively. Now we have A, which is nothing but the length of the x-intercept of the circle. The x-intercept is given by 2 times square root of g squared minus c. So we can simplify this to get a squared equals to 4 times g squared minus c. So let this be equation number 2. And similarly, we can also define the y-intercept. So the length of the y-intercept, which is nothing but the rod of length b, this will be equals to 2 times the square root of f squared minus c. So squaring it gives us b squared equals to 4 times f squared minus c. Let this be equation number 3. Now here c is the constant. C is the parameter that we need to get rid of. So let's do one thing. Let's do 2 minus 3. So when we subtract 3 from equation number 2, we're going to get a squared minus b squared equals to 4 times g squared minus f squared. Fine. Now what's g and f? G and f is actually the G and F can represent the center of the circle, which is having the coordinate negative g comma negative f, meaning we can again rewrite the equation as a squared minus b squared equals to 4 times negative g whole squared minus negative f whole squared. Now to find out the locus of this center C, all we have to do is replace the value. So we're going to replace the value of negative g with x and the value of negative f with y, such that we get a squared minus b squared equals to 4 times x squared. We're replacing negative g with x squared, minus replacing negative f with y, we get y squared. So this is going to be the locus of the center of the circle, and it's given by the equation a squared minus b squared equals to 4 times x squared minus y squared. Hence proved.